here we are. This is service data for television receiver Pye T22X. So here we go. Some of the places that actually would have supplied the TVs where they would have been sold from. Pye Limited. Yeah, so you've got your alignment data there and everything, and sensitivity figures and so forth, alignment of the 5.5 MHz sound IF amplifier circuits and so forth. That there is your printed circuit board layout, and showing all the component locations and where to find things if you happen to get lost in the street map. A couple of this actually doesn't quite match the board, and this doesn't quite match that board. There's a few components which are on there which aren't here, but are actually shown in the circuit. So obviously they would have made modifications to these things over the years. So tuner unit, alignment and everything, general alignment, oscillator adjustments, and just a sort of a general sort of a diagram of the tuner and what everything does on there. Heater, AGC, HT, retaining spring, adjustments and everything, so forth. I've actually had very little. Actually, the tuners in the past, the tuners have actually given me very little grief. It's mainly everything else that I've had problems with. The tuners, I've had the odd valve fall over and basically just dirty contacts in the turret and the turret side of things and the in there, but generally most of the time the tuners sort of seem to be okay. No doubt my day will come where I'll have to pull one down and service it and adjust it, no doubt. So this is I don't even actually see this properly, but I'm sort of just trying this camera out sort of properly for the first time. So it looks clear in the viewfinder, but whether it's all out of focus when I kind of play it back on the computer is a different thing. So yeah, so just bear with me and I will. The circuit actually folds out. Again, nice. One thing about Pyes is their circuits were quite nicely laid out. You had your waveform table there with all your voltages and what things should be. Yeah, so okay, so what have we got here? Got your tuner, front end there, there's your tuner there, PCF86-7. Yeah, it's funny, they've actually used a couple of P series valves in the tuner, so there must be, obviously, must have been reasons for doing that. So, okay. So you got a 6EH7 EF183 for first vision IF. Second IF is an EF184, 6EJ7. Some of those valve numbers might be familiar to you guys. Video detector there. It's your sound IF, which is 6EW6. I noticed some of these numberings are probably similar to some of the American sets, whereas the EF and P series numbers are probably more familiar to the European sets and so forth. So sound IF there, and sound detector, which is the sound detector is a 6B. It's a 6B, 6 isn't it? Hang on, sound detector, it's V5, must be V6. 6GX6, sorry. And it goes down to here. It's got an ECL86. Pentode sides for the audio, and the triode side of it is for the AGC. So, output transformer, and it goes to the speaker, and volume control up there. Okay, moving back down here again, vertical output transformer, contrast control, vertical oscillator there, and vertical output. This is an ECL 86 or 6G V8. The ECH 200 here, your sync separator and sync clipper. Again, pentode side does the sync separator, sync clipper is the triode side. Moving further along, you've got the ESL84 or 6DX8. Noise detector is the triode side, and the pentode side is the video amplifier. Of course, it incorporates the AGC side of things. Moving down here, see the power supply. See typical voltage doubling circuit for the power supply. Main transformer there. That's your heater circuit there, heater chain, your choke, your brightness control. This is a horizontal oscillator, your discriminator there, flywheel, horizontal oscillator, of course. Moving along here, this is the line output EHT section, EL366CM5, it's your line output valve, and 6AL3E88 is the boost diode, and DY87 or 1S2 is the EHT rectifier. So it's a fairly conventional line output stage. Oh, okay, yeah, one of those calls is width and the other one's linearity. So that would actually make sense. And your set EHT adjustment there as well. Generally, you sort of set the boost voltage generally around sort of 800 odd volts or lower. Basically, I adjust it so that basically the pitch is just coming on the sides. You know, it just makes the line output transformer work a bit nicer, and there's less strain on the transformer and all the sort of things. So just keeps it a bit less stressed. And down here, you've got all your pin voltages and what they should be. Oh, there we go. This diagram applies to all sets of serial numbers above 282484. And you see this one here is 394988. That might explain why there was a few components which said that were on the board, and yet they weren't on the set. That would be why there's a few components that said they were there and they weren't. So that would pretty much explain that. Yeah. So I guess I might as well move on to explaining some of the problems I had with this set, because one of them was a pretty good one. It just about drove me insane because I just run out of ideas. I couldn't fathom what on earth was going on. I'd kind of replaced all the components in the area, and it didn't really leave much at all. So yeah. The vertical had a problem where after sort of half an hour or 20 minutes, something like that, the picture would increase in size, and the thing would start start rolling, doing all sorts of crazy bloody nutbar things. And I of course changed the valve and changed, again, because all these resistors were just crapped out. So I changed them all. Excuse me, made no difference. So I got my free and started spraying freeze around various things, and sort of got up here and noticed spraying around here would make the picture sort of come back to normal size and would sort of stop rolling. And what it turned out to be was one of these disc ceramic caps was sitting right there. It was actually breaking down under load, and the heat was causing the thing to break down. So I changed it, and that problem pretty much went away. It's quite funny. It was one of these disc ceramic caps, and again, sort of never sort of had one of those. I've had one or two fail, but it's always there's always electrolytics and that sort of thing that seem to fail. But I guess it's the first time for everything. In this bag is pretty much what I replaced in here. What I have replaced, as you can see. So that's where the screws for the back went. Okay. Yeah, this one here, this critter here. This is the offending article. This thing here was the one causing the problems in the vertical. Yeah, here we go. That's one there, C59. That's one that was causing all sorts of problems. And yeah, basically look at that. Yeah, basically in series with the top linearity pop, and it was actually, it must have been breaking down because it was causing the thing, just causing the thing to go berserk basically. So yeah, it was all sorts of problems, height and things, and the set, yeah, just pitch in general would just the shape would just turn to crap after a while. So that one there was the offending culprit. Changed all the resistors in here as well, so be on the safe side. Yeah, you sort of see a few of these here. That one's pretty baked. It's a UCC 0.22, 160 volt. I think it measured okay, but you know, as you guys well know, you know, you leave them in, and then 6 months later, in the track or year down the track, something else goes wrong, and you end up actually end up revisiting the set to do further work on it. Not sure where that was, but as you can see, it's a bit cooked. Here's one of these that was the cathode bypass cap for the audio stage. That checked about 300 UF. And this one here was the coupling cathode bypass capacitor on this in the sound detector side of things, and that cap was actually open circuit and read about, well, open circuit, it's gone low. It read about I think about 500 nanofarad or something, or 0.005 or something on my cap tester. And what's this one situated here? And surprisingly enough, when I changed it, I noticed a remarkable improvement in the sound. So yeah. So yeah, obviously must have affected the way that circuit's operating, and yeah, the sound's actually improved quite a bit. It's quite thin and quite weak before, but now it's got a lot more volume and a lot more bass. So obviously that's improved. That's well, obviously, because yeah, well, obviously it's all to do with, you know, detection and basically feeding the audio to the output valve. What else? What else here? These are the offending resistors that are really prone for drifting. Really bad, these things here. So as you can see, there's quite a few I've actually replaced. I know I'm repeating myself, but so sorry I'm rambling a wee bit here. What I might do, actually might get my multimeter and sort of show you how bad some of these were. So just give us a sec and I will find my flute with some crocodile cleaves and I'll show you how bad some of these were. So back in a sec.